Welcome to another highlight video for the latest features in CUDA developer tools. This video will give you a rapid-fire overview of several new features we've recently added to our CUDA profiling, debugging, and IDE integration tools. Nsight Systems is a powerful system-wide performance analysis tool that allows you to examine your CPU and GPU interactions in order to identify the largest opportunities to optimize your code. The latest releases add the capability to display network interface metrics from NVIDIA networking adapters, formerly Mellanox, whether running over InfiniBand or Ethernet, on the timeline. Now you can see when network communication is occurring correlated with CPU and GPU activity to identify how these communication patterns and network traffic may be impacting performance. There's also new support for multi-report tiling, which allows the aggregation of reports into a single view. Reports collected sequentially can be tiled horizontally to create one long timeline, and reports collected on multiple nodes can be tiled vertically to see correlations on a single timeline across multiple nodes. For detailed profiling of CUDA kernels, we turn to Nsight Compute, where we have added several new features to help understand what's going on under the hood of a CUDA application running on a GPU. The new occupancy calculator activity helps you understand the hardware resource utilization of your kernels and model how adjustments could impact occupancy. Occupancy is a ratio of active warps per SM to the theoretical maximum number of active warps. Low occupancy may represent kernels that are too small or limited by one or more resources. There's also a new register dependency visualization feature that helps identify long dependency chains and inefficient register usage that can limit performance. The SAS view in the source page has new columns that track all the potential writes for a register each time it is read. Tooltips show you the register name for each dependency line. In addition to profilers, our debuggers and IDE integrations have added new features as well. Nsight Visual Studio Edition now integrates into the latest Microsoft Visual Studio 2022, and we've improved performance for generating core dumps by up to 5 times in some cases. We've also given particular attention to enabling optics developers with the last several releases. Optics is an application framework for achieving ray tracing performance on the GPU. Nsight Compute has added support for profiling optics kernels, intercepting optics API calls, and showing them in the API stream window, as well as tracking optics 7 resources in the resources tool window. Users can see the properties and lifetime for optics objects. Understanding when objects are created, destroyed, and interacted with can reveal unexpected behaviors that may cause performance or correctness issues. And as a sneak peek, we're also working on an acceleration structure viewer for optics applications in Nsight Compute. Acceleration structures describe a rendered scene's geometries for ray tracing intersection calculations. Users create these acceleration structures, and optics translates them into internal data structures. The description created by the user may be error-prone, and it's sometimes hard to understand why the rendered result is not as expected or where performance can be further improved. The Acceleration Structure Viewer allows users to inspect the acceleration structures they build before launching a ray tracing pipeline. Once they are built by optics, the viewer allows users to navigate through them in a 3D visualizer and view the parameters used during their creation, like build flags, triangle mesh vertices, and AABB coordinates. It's useful to identify overlaps or inefficient hierarchies, resulting in subpar ray tracing performance. This feature will be coming out in a future release. CUDA, which is the public CUDA profiling tools interface, has added support for optics as well. CUDA can profile both internal and user kernels using the profiling APIs, and the Compute Sanitizer automatic correctness checker now supports optics analysis. You can identify correctness issues like invalid writes in optics applications. Optics developers, if you haven't looked at our developer tools recently, now's a great time to check them out. Lastly, I want to mention the upcoming support we have added for the new NVIDIA Jetson AGX Orin SoC. Previous versions of our tools would support SoCs like this one with remote connections, requiring an additional host system or CLI-only collections that needed to be manually copied elsewhere for analysis. In an upcoming release, developers will be able to run the Nsight Developer Tool Suite natively on the dev kit with the full GUI, just like a desktop PC experience. This includes code development and debugging with Nsight Visual Studio Code Edition, platform profiling with Nsight Systems, and detailed kernel analysis with Nsight Compute. The GUIs will also now run on SBSA platforms natively. No longer are these dev kits considered just a target for some larger host. This was just a quick list of some of the new things we've been working on, and I hope you saw something that piqued your interest. We have detailed information on all these features in our documentation, and don't hesitate to reach out on the forums if you have any questions. Thanks for watching.